Well, willkommen, meine Damen und Herren. Yes, welcome. And let us continue with reactions. We've already covered three of the big five, right? We've covered synthesis and we've covered decomp, and we love those because we know they're just the opposite of each other. And then we've covered combustion, and that's pretty simple because all you're doing is taking some kind of a hydrocarbon and you're going to react it with oxygen, and you're always going to form the same things if it's complete combustion, and that is carbon dioxide and water. So let's move on to the next type. It says, consider a reaction of aluminum with a solution of lead 2 nitrate. Okay, well, I can recognize this. That is a metal, but what's this? Well, and it's a solution. Okay, I'm not sure we've learned anything about this when I have just a metal and this is a polyatomic dissolved in water. Yeah, this is something new. And this is what we call, here, let's go with our reactions. Yeah, we got types. And under our types, we have synthesis, and we have decomp, and we have combustion. And now we're going to add the next one. And this is what we call a single replacement reaction. Or some people call them single displacement. I tend to call them single replacement reactions. And they take the general form. Really, there's two general forms. I have a metal, and then I have I'm going to make this a funkier M. I have a different metal that is in solution with an ion. Okay, and what happens is the individual metal comes in and replaces the metal in solution, and so then I get my funky looking metal here as a solid, and my block M now is with my ion in solution. Okay, that's form one. Now form two is kind of the opposite way. I will have a halogen, right? And so my halogens are always, I'm going to go with a hal, we'll call that. There's my halogen, and my halogen is going to react, and I'm going to have a metal with another halogen, and let's make this, how do I make this a funky H? We'll call that my funky H. That's my other halogen. And what's going to happen? This halogen is going to come in here and replace that halogen, and I end up with my funky H halogen and then my M halogen. So these are both forms of single replacement reactions. Sometimes you'll see it as A plus BX yields B plus AX. Okay, that's kind of the real general form, but we have two types. We have metal replacements and halogen replacements. Now, I think of this more along the lines of the, I think of this as the strong senior boy and then freshman boy and freshman girl. And what happens? Okay, no one has any interest in this girl when she first comes to school, right? She's a little freshman. But then a freshman boy starts dating her and they become a couple, right? And all of a sudden, she starts looking pretty hot. And now the big, strong senior boy does what? He comes up over here, he kicks sand in the face of the weenie freshman. He runs home and cries and ends up all by himself. And now the senior boy has the hot freshman girl, right? So that's kind of the way I look at single replacement reactions. Or it could be the opposite with the senior girl beating up the little senior freshman girl to take the sophomore boy, right? There we go. Okay, I know that's an insult to somebody, but that's okay. Now, let us take a look at this one. What do we have going on here? I have aluminum, solid, and it is reacting with lead 2. Lead 2, that means what? Its charge is plus 2. Nitrate. Nitrate is a 1 minus. That means I need 2 of these. It is a solution, so it's aqueous. Now, what's going to happen? The aluminum is going to replace the lead. So my lead is going to be by itself, crying. It no longer has a date. And my aluminum now picks up the always beautiful nitrate, right? And nitrate is -1. Aluminum makes a 3 plus as a ion. It's going to be in solution, and that means I need 3 of those. There we go. That is my single replacement reaction. You guys give this one a shot. Okay, reaction of solid sodium with a solution of silver chlorate, silver chlorate. What's going to happen? My sodium's going to come in here, beat up the silver. The silver's not really beat up. It's just going to replace the silver. I'm going to make solid silver plus what? Sodium chlorate solution. Hey, that's pretty easy. Yeah, it is pretty easy. Good. And what do we call this? We call this a type. Let's talk about my types, excuse me. The types of this type number 1 of a single replacement. Type number 1 is what we call a metal replacing a lower metal in solution. Okay? And you understand what we mean by lower metal in a second. Next, here we go. Consider dropping a piece of silver in a solution of potassium sulfate. Hey, piece of cake, right? Sure. I have silver. And what happens? It reacts with my potassium sulfate. Sulfate is, oops, no, that's not sulfate. Sulfate is SO4, 2 minus. Potassium is a +1, so I need 2 of these. There we go. In solution. And what's it going to produce? Well, you guys can do this, right? And the answer is no reaction. What? Wait, what? Well, silver is kind of like the weak little brother, and potassium's like the strong senior. How is the silver freshman going to beat up potassium? The answer is it's not going to happen. Well, how do I know this stuff, Mr. Smith? Well, there's some nice people who have put together a chart for us. This is called the activity series of metals in aqueous solution. And essentially is a pecking order. It's kind of king of the hill. This is the king of the hill of metals. And who's the king overall? Lithium. Nobody can beat up lithium. No one can replace lithium. And who is the weakest? Gold. That's the little stepchild that you kick and throw and mud at and put their heads in the toilet and give them a, dirty swirlies, right? Yes. So that is the order. And we do stick hydrogen in here. But what does this mean? That means magnesium will replace chromium in solution, but nickel will not replace cobalt in solution. And the one we were looking at was what? Silver. Would silver replace, what is this? Potassium? Where's potassium? No. Wow, potassium is like the big kahuna. Will silver be able to replace potassium in solution? The answer is no. But can potassium replace silver? Yes. So if potassium is by itself and silver is in solution, then potassium can go in solution and replace the silver. Okay, give this one a shot. Well, what are we going to do? We have magnesium plus aluminum chloride. Okay, aluminum chloride. That's a -1. That's a +3. So, oops, I don't need brackets, do I? How's that? And it's going to be a solution, aqueous. Now, the question is, will it react? Well, let's go to our table. And where's magnesium? I can't see. You've written all over it, Mr. Smith. Where's magnesium? There's magnesium, and we're comparing it to what? Aluminum? There's aluminum. Which one is higher? Magnesium is higher, so that means magnesium will replace aluminum. Is that what we're looking for? Will magnesium replace aluminum? The answer is yes. And what am I going to make then? Aluminum solid plus magnesium chloride, and I have to balance this. Okay, what's balance? It looks like I need maybe 3 of these, which means I need 3 of these, and I need 2 of these, and 2 of those. There we go. So if we go back to our notes, we want to put a little star here, right? A metal replaces lower metal, and how do we know if they're lower or not? We use the activity series. You use the activity series. Now, for honors chem, you're going to be able to use that table, but for AP chem, you're going to need to memorize that. So it won't hurt for you to start thinking about, memorizing this table. Good. Going further. Next, dropping a piece of aluminum in a solution of hydrochloric acid. Okay, now how is this one different? I have metal, and what am I mixing it with? Well, I'm mixing it with an acid. Okay, so here we go. We have a new type of single replacement reaction, right? And it is number 2. It is a metal, and what's it going to do? It's going to replace hydrogen in an acid. And guess what? We're going to have to use our activity series. Okay, does that mean all metals do not replace? Yes, it means all metals do not replace hydrogen in acid. So, aluminum, solid, plus hydrochloric acid. Hydro means it's binary. Chloric acid yields what? Well, first, let's take a look at our activity series. Where's aluminum? Here's aluminum. Where's hydrogen? Okay, here's my hydrogen. So it will replace hydrogen. It's above it, so aluminum will replace hydrogen. Good. So that means my aluminum's going to come in here. Yoink. Hydrogen's going to be knocked over there. Doink. And I get what? H plus AlCl. Well, Cl is a -1. Aluminum is a +3, so I need 3 of those. Oh, but H can't stand alone, right? I brought clay from our new house. Must be diatomic. We know that's a gas. Good. So that means when I have this single replacement reaction where I'm replacing hydrogen, I'm going to form hydrogen gas. Now we need to balance this. Ach du Liebe. I need what? I need at least 2 of these. Well, that doesn't work. So if I had 2 of these and I have 3 of those, I need 3. I'm going to need 6 of these guys, which means I need 2 of these guys, and I need 3 of those guys. I need 2 of those guys. 2, 6, 6, 6, 6, 6. Woohoo! There we go. That is our answer. Next, I think this is one for you. Give it a shot. Well, what do we have? I have magnesium, and I'm dropping it in nitric acid, Mg, solid, plus nitric. It means it comes from nitrate. Nitrate is NO3, aqueous. We need to check our activity series. Where is magnesium? I still can't read this because I keep making a mess of this. Here is magnesium. Is it above hydrogen? Yes, it is. So that means magnesium will replace hydrogen. It means my magnesium is going to go through here. My hydrogen is going to come over here. I'm going to form hydrogen. Need gas. I need 2 of those. It's diatomic. It's going to form what? Magnesium. And what's the magnesium going to have as its state? Nitrate. Nitrate is a -1. Magnesium is a 2+. That means I need 2 of those. It's aqueous. Cool. Now I need to balance this. Oh my gosh. Put a 2 here, and then I have 2 hydrogens. Hey, that's all there is to it. Wunderbar. Going farther. Dropping a piece of silver in solution. Okay, so we drop a piece of silver. That's easy. Silver, solid, plus hydrochloric acid, HCl. Good. And what's it going to form? Well, that would form what? Silver's going to come over here and do this. And so I should form H2 gas plus what? Silver chloride. Hey, that is about as easy as can be, right? Of course it is wrong. Why is it wrong? Because I didn't check my activity series. Where is silver? Silver's right here. Can silver replace hydrogen? The answer is no. So what does that mean? That means nothing happens. there's no reaction. And that's why you girls love silver rings with diamonds in them, because when you wash the sink with your vinegar, you won't dissolve your ring. Good. Here we go. Next one. I'm going to drop a piece of aluminum in water. So Al plus HOH liquid. And what's going to happen? Well, this is a new one, right? This is not an acid. This is not a metallic solution. So what is it? Well, we need more help, Mr. Smith. Help us, Mr. Wizard. Good. Number 3. And what is it going to be? It's a metal, which will do what? It will replace hydrogen in water. Good. You think there's going to be a star coming? There's a star coming, and what is it? Well, the star is only group 1 and group 2 do this. In fact, not all group 2. Really, on the group 2, we want to focus on barium, strontium, and calcium. So only group 1 and what we call heavy group 2 metals do this. So that means if it's not from group 1 or group 2, heavy group 2, barium, strontium, calcium, you're not going to replace hydrogen in regular water. Okay, so let's go to our question here. Aluminum. Where's aluminum on my periodic table? Well, it is not in group 1 or group 2. It's in group what? Wow, heck, it's underneath boron. It's group 3A, meaning group 13. So will this replace hydrogen in the water? The answer is no. There's no reaction because it's not from group 1 or group 2. Hey, I like those. Easy to balance. I'm going to drop a piece of potassium in water. K plus HOH. Where is K on the periodic table? Hey, K is my group 1. So will it happen? Yes, it will. That means my K is going to come in here. It's going to knock out a hydrogen. And what's going to happen? I'm going to get hydrogen plus KOH. I need 2 of those because it's diatomic. This is going to be aqueous. Hey, by the way, now do you see why I write water as HOH? It's kind of like an H plus and an OH minus. When this K comes in, does this K ever knock out this hydrogen from hydroxide? No, it only knocks out this hydrogen, and the hydroxide is left whole. That's why I like drawing water this way, because it helps me remember what I form over here. Now, we need to balance this. I need 2 of these, and that means I'll need 2 of these, and I'll need 2 of these. That is my metal replacing hydrogen in water. Okay, here we go. 2 more slides. Bubbling fluorine gas through a solution of sodium chloride. Okay, what is fluorine? Well, fluorine we know is F2. Is it a metal? No, it's not a metal. Aha. So that means we're looking at another type of reaction, the 4th type of single replacement reaction. And thankfully, the last type of single replacement reaction. Number 4, you have a halogen. What are halogen? Well, group 17, right? Group 17, you know, the chlorines, the fluorines, the iodines, and so forth. Halogen replacing lower halogen. And that lower halogen is in a compound. Okay? And how are we going to figure out what is the lower? And the answer is C what? Not activity series, because that's for metals. It's going to just be C periodic table, because this periodic table tells us all about the reactivity of my halogens. Ooh, that's nice. Good. So what's going to happen here? I have fluorine gas, and it's going to react with sodium chloride. And what's it going to want to do here? This is what a solution. Well, the fluorine, is it going to want to remove the metal? No, no, no. This is a halogen. What does the halogen want to replace? It wants to replace another halogen, right? Good. So my fluorine is going to replace my chlorine. And what am I going to form? Sodium fluoride plus chlorine gas. Okay. And let's see. We need to balance this 2, 2. Got it? Okay. Now, I said use the periodic table. How do we use the periodic table? Well, very simple. We look at our halogens here. And this is the order. This is the strongest or most reactive, you might say, and this is the weakest, which means what? It means fluorine will replace all of them. Chlorine will replace everybody but fluorine. Bromine will replace iodine and astatine, and iodine only replaces astatine. And so that is the relative strength, activity strength, you might say, of my halogens. Good. Last slide. We're going to mix bromine and sodium iodide. I have solutions. Okay, so that means I have bromine in solution. Oops, got to be Br2. I brought clay from our new house. And sodium iodide. And it is a solution. And what's going to happen, my bromine is going to want to replace my iodine, and my iodine wants to come over here. So I would form iodine. That could be a solid, I'm not sure, or a liquid, or I think it's a solution in this case. It'll be dissolved in our water. Plus sodium bromide aqueous. And by the way, some of these I don't expect you to know because I don't know them all. Good. And we want to balance this. I need 2 here and a 2 here, but we want to check. Bromine, can bromine replace iodine? Where's bromine? Here's bromine. Here's iodine. Bromine is above iodine, so it can replace it. Woohoo! There we go. That's all you need to know about single replacement reactions. See you next time.